Alright, we are starting a new unit called stoichiometry. And this is a really scary looking word that is actually not that big of a deal. The metry part means measure, and the stoichio part means elements. So we are basically, this is a way that we measure elements and also compounds. But before we can do stoichiometry, we need to do a little bit of pre-stoich stuff. So let's talk about how the coefficients in a reaction tell you how many moles of each chemical are found in the reaction. For instance, in this reaction C2H4 plus 3O2 yields 2 CO2 plus 2 water. In this reaction, there is one C2H4 molecule, there are 3 O2 molecules, 2 carbon dioxide molecules, 2 water molecules, but you could also say there is 1 mole of C2H4, 3 moles of O2, 2 moles of CO2, and 2 moles of water, because the ratio stays the same. So when it asks how many moles of oxygen gas are in this formula, there are 3. How many moles of carbon dioxide? There are 2. How many moles of water? There are 2. How many moles of ethene, the C2H4? There's 1. We're just taking the same number of moles as the coefficient. The number of moles is equal to whatever the coefficient is. Remember, a coefficient is the number in front. Just like in your math class, if you write 4x, that number in front, the 4, that is a coefficient. In chemistry, the number in front of a chemical is a coefficient. So let's talk about how we calculate with stoichiometry. Stoichiometry is the way that we calculate amounts of reactants or products needed in a chemical reaction. It's like using a recipe. If you're given a recipe, you can calculate how much of each ingredient or each reactant you need to make your tasty, tasty food product or meal. For instance, one example is a recipe for a peanut butter sandwich. You use 1 serving of peanut butter, 2 slices of bread, and 1 peanut butter sandwich gets made. So we could write that as 1 peanut butter plus 2 bread makes 1 peanut butter sandwich, which is a PB and 2 breads. In chemistry, we can find the ratio of things needed to make our food. For example, there is 1 peanut butter serving for every 1 peanut butter sandwich. We could also write that as 1 PB over 1 PBB2. Other ratios: 2 breads for every 1 sandwich. Or we could flip it. We could say 1 sandwich for every 2 breads. Or we could even compare the peanut butter and the bread to each other. We have options, lots of options. We can use all these ratios and more to answer and calculate answers to questions. Like, if I have 80 slices of bread, how many peanut butter sandwiches can I make? I know you can do this in your head, but you're not always going to be able to do it in your head, so let's talk about how we show our work for this. Just like in our mole unit, we're going to end up with some fractions where we take the given 80 slices of bread over 1. We're still going to do what goes up must come down, so if there was bread on top, bread's going to come on bottom. And peanut butter sandwiches is what they're asking me to switch to, so I'm going to use PBB2 as my peanut butter sandwich. Now I need numbers to compare bread with peanut butter sandwiches, and those numbers are going to come from my ratio right here. And remember, the numbers in this ratio came from my reaction originally. So 1 PBB2 over 2 breads. If I multiply the top and divide the bottom, I'm really doing 80 over 2, which is 40 sandwiches. Again, I know you could do that in your head. That's not the point. We have to be able to show our work for when it stops being possible to do it in your head. Which it will, I guarantee. You will not be able to do it in your head by the time the unit's over. If you have 5 servings of peanut butter, how many slices of bread? Again, we're going to do a couple fractions and put the given over 1 for our first fraction. We're going to do what goes up must come down again. We can only use each unit twice, so just like in the mole unit. So we're going to switch to our new unit, bread. We did not earlier write a ratio comparing bread on top to peanut butter on bottom. We did have one that was flipped. And remember, the numbers in that came from our original reaction. Those were the coefficients. So really, I can use those coefficients again. This 2 on the bread here is coming down here. And this 1 on the peanut butter here is coming down here. That's where we're getting those numbers from. And then, just like before, multiply the top, divide by the bottom. You're doing 10 over 1, which is just 10. You need 10 slices of bread when there are 5 servings of peanut butter. An easy way to figure out these ratios is to draw what we call a bridge from one food to the next. Then it points out whatever numbers should go in your ratio. So I'm going to rewrite down here the reaction that we had at the top, just so it's easily accessible. And this example says if you're making 20 sandwiches, how many slices of bread do you need? So again, I need a couple fractions. Take the given 20 sandwiches over 1. What goes up must come down, so sandwiches are going to come on the bottom. And they're asking me to find bread, so I'm going to put bread on the top. Since I'm starting with sandwiches and looking for bread, I can draw a little bridge starting at the sandwiches, pointing to the bread, to tell myself these are the numbers I need to go in my comparative ratio. There is 1 sandwich, so I'm going to put 1 sandwich here. There are 2 breads, so I'm going to put 2 breads here. From there, again, multiply the top, divide by the bottom. Dividing by the bottom is just dividing by 1. We don't really have to deal with that, so 20 times 2 makes 40 bread. That's my final answer for this one. And that's the basic idea behind stoichiometry. It's going to get a little more complicated, obviously, but that's the basics. So that's page 10. We're going to move on to page 11 in another video.